Hi everyone! In today's video we'll talk about SQL injection or SQL injection. Depending on where you're from, the pronunciation would be different. For me, I will pronounce it SQL, but you have to know that people sometimes pronounce it SQL. Anyway, so SQL stands for Structured Query Language, and an SQL injection or SQL injection is an attack on the web application database server that causes malicious queries to be executed. When does it happen? So it happens when the web application communicates with a database using not properly validated input from a user. And what is the impact of it? So an attacker could potentially steal, delete, or alter private and customer data. The attacker can also attack the web application authentication methods to private or customer areas. This is why, as well as SQL injection being one of the oldest web application vulnerabilities, it can also be the most damaging one. In the next part of the video, we'll be talking about database and what's the SQL language. If you already know that, you can just jump directly to what is an SQL injection chapter. If not, continue with me. So, what is a database? A database is a way of electronically storing collections of data in an organized manner, and it is controlled by a database management system or DBMS. The DBMS fall into two camps, either relational or non-relational. So as this video will be more focused on the relational type of database, that's what we're gonna talk about, but we'll still explain the difference between the two later on. So within a DBMS, we can have multiple databases, like this one, or again, this one. So for example, we may have a database called shop, and within this database, we want to store information about products that are available to purchase, users who have signed up to our online shop, and information about the orders we've received. And we'd store these information separately in the database using something called tables. The tables are identified with a unique name for each one, and we can see the structure here in this diagram. But we can see also that how a business might have other separate databases to store staff information or accounts for the team. So what are tables? A table is made up of columns that are going across the top from left to right, containing the name of the cell, and the rows going from top to bottom, with each one having the actual data. So each column, better referred to as a field, has a unique name per table. When creating a column, we also set the type of the data it will contain. For example, it can be integer or numbers, strings like standard text, or dates. Some databases can contain complex data such as geospatial information, which means they contain location information. Setting the data type also ensures that incorrect information isn't stored, such as the string hello world being stored in a column meant for dates. And if this happens, the database server will usually produce an error message. A column containing an integer can also have an auto increment feature enabled, giving each row of data a unique number that grows with each subsequent row. By doing that, it creates what is called a key field. So a key field has to be unique for every row of data, used to find that exact row in SQL queries, while rows or records are what contains the individual lines of data. So when you add data to the table, a new row or record is created, and when you delete data, a row or record is removed. Now that we've talked about tables and database and relational, let's see what's the difference between the two, like relational databases and non-relational database. So a relational database stores information in tables. The tables have shared information between them. They use columns to specify and define the data being stored and rows to actually store the data. The tables will often contain a column that has a unique ID called a primary key. So the primary key can be used in other tables to reference it and cause a relationship between the tables. And that's why it's called a relational database. Some common relational databases are MySQL, Microsoft SQL Server, Access, PostgreSQL, SQLite, and so on and so forth. While non-relational databases, however, sometimes called NoSQL, are any sort of database that doesn't use tables, columns, and rows to store the data. A specific database layout doesn't need to be constructed. So each row of data can contain different information, giving more flexibility. Some popular databases of this types are MongoDB, Cassandra, and Elasticsearch. So what is SQL? SQL, or Structured Query Language, is a feature-rich language used for querying databases. These SQL queries are better referred to as statements. So the SQL commands that we'll see are used to retrieve with select, update, insert, and delete data. There are more commands that exist, but these are the ones that we'll use and we'll see here in this video. Although somewhat similar, some database servers have their own syntax and slight changes to how things work. All of these examples that we'll see are based on MySQL database. You'll still be able to search for alternative syntax online for the different servers. And something that is worth noting is that SQL syntax is not case sensitive. So writing it uppercase, lowercase doesn't matter. Now, let's see the first query type, the select query. It is used to retrieve data from the database. So for example, if you have this table and we want to retrieve all the information in the table, we can use select asterisk from users. And that will give us back this as a result. So the select tells the database that we want to retrieve some data. The asterisk tells the database we want to receive back all columns from the table. And from which table? It's from the table users. So we are telling the database to retrieve the data from the table which is named users and all the data. And the semicolon at the end of the statement is what ends the query. So the next query, or this one, says select username, password from users. So this one, instead of selecting all or retrieving all columns, what we did with the asterisk before, we are retrieving only the username column and the password column. And so that's what the database will give us back as a result. Now, if you want to retrieve only the first, for example, row, we can use the limit 1. So this, as you can see at the end, so select asterisk from users limit 1, forces the database only to return one row of data. So you have to know that we can still use limit in another way. So for example, if you want to instead skip the first one and retrieve the second one, so by after skipping the first one, that means we'll retrieve this one. So we skip the first, which had ID number 1, and we'll get the one with ID number 2, and we limit to one row only. And if we want to skip the first 2, we would use limit 2, 1. And so that will skip the first 2 and retrieve the third one. And because we had just one row, we'll get just the third one. So we need to remember that the first number after limit tells the database how many results we wish to skip, and the second number tells the database how many rows we to return. And also we can also specify the exact data we require the database to return to us, and that is by matching a specific information. So for example, select asterisk from users, and that's the next part is what is different, where username, so username here, it's the column here, equal admin. So we'll be searching for exactly this, and that's the row that the database will retrieve for us. And if there is no admin username or no username with admin, which value, the database will retrieve nothing. It will just tell us that there is nothing to retrieve. We can also, instead of returning the rows that equal something, we can return the rows that doesn't equal something. So here where username don't equal or doesn't equal admin. So for the not equal, we use this exclamation point and equal, and then we'll get these, the first row and the third one. We can also select different rows where the usernames equal something or something else, like username equal admin or username equal John. And that's what we are gonna end up with. We can also use the AND operator to get the database to return something in particular, like here, where username equal admin and password equal P4 SS Word. And so we'll end up with this. We can also use like clause that allows us to specify data that isn't an exact match, but instead either starts with something, like here we are asking for username that starts with a, username like a %. So the percentage sign is a wildcard character, and here it means we are searching for something for usernames that start with a, and we end up with this one. We can also ask for usernames that ends with something, and then we'll be using the percentage at the start. So where we'll have select asterisk from users, where username like %n. And so any row that has a username that ends with an n will be retrieved. And here all of them have usernames that ends with an n. We can also select for rows with a username containing the characters mi in them. So by putting the percentages at the start and at the end, and you'll end up with only this row because there is only admin which have the me in it. So now that we've talked about select statement, let's talk about the union. So the union statement combines the results of two or more select statements, and that is to retrieve data from either single or multiple tables. The rules to this query are that the union statement must retrieve the same number of columns in each select statement, and the columns have to be of a similar data type, and the column order has to be the same. For example, let's say a company wants to create a list of addresses for all customers and suppliers to post a new catalog, and they have already one table called customers with the following contents, so ID, name, address, city, and postcode, and another called suppliers with these contents, so still ID, company, address, city, postcode. So using this statement, this SQL statement, select name, address, city, postcode from customers. So from the first one, name, address, city, postcode, from customers, union, select company, address, city, postcode from suppliers. We'll end up with this information. Then there's also the insert statement. The insert statement tells the database to insert a new row of data into the table. So for example, we have this table. When we say insert into users, we are telling the data, so into users tells the data which table we wish to insert the data into. Here, it's the table users. Then username, password. This provides the columns we are providing data for, and then values. So values Bob password 123 provides the data for the previously specified column. And so we'll end up with this result at the end. While the update statement tells the database to update one or more rows of data within a table. So if we get this table and we ask for this update users set username root password pass123 where username equal admin, it tells the database to update first the table in the table users, then select the fields or that we wish to update, and we separate them by comma. So here we want to update the username root and password pass123 pass123 where, and then finally, so similarly to the select statement, we can specify exactly which rows to update using the where clause. Here, where username equal admin, so the only row that will be updated from this query is the row with the ID 2, and it gets to root and pass123. And the last SQL statement that we'll talk about now is the delete statement. So the delete statement tells the database to delete one or more rows of data. The format for this query is very similar to the select one. So we can specify precisely which data to delete using the where clause and the number of rows to be deleted using the limit clause. So for example here, if we want to, we can put like delete from users where username equal Martin. So the row that will be deleted here is the row with ID number 3. And so we end up with this. So the row with Martin, this is where it was deleted. And we can also delete all the data in a table with using statement like this one, delete from users, and it will end up with a table with no data. So now that we have the basics of what is a database and what is SQL, let's go into what is a SQL injection or an SQL injection. The SQL injection is the point wherein a web application using SQL can turn into a SQL injection is when a user-provided data gets included into the SQL query. So for example, what does it look like? Let's take this scenario where we've come across an online blog and each blog entry has a unique ID number. The blog entries may be either set to public or private, depending on whether they are ready for public release or not. The URL for each blog entry may look something like this. And so from this URL, we can see that the blog entry being selected comes from the ID parameter in the query string. So the web application needs to retrieve the article from the database and may use an SQL statement that looks something like this, where you'd have something like select asterisk from blog where ID equal 1 and private equal 0, limit 1. The SQL statement is retrieving an article with the ID number 1, and the private column would be set to 0, which means it's able to be viewed by the public, and limits the results to only one match. And as was mentioned at the start of the SQL injection, when I said that the SQL injection is introduced when user input is introduced into the database query, here that would be the ID parameter from the query string is used directly into the SQL query. So let's pretend that article ID 2 is still locked as private. So if we do this, it couldn't be viewed on the website. What we could do is add this, the semicolon dash dash. So which would then produce this SQL statement. So the semicolon in the URL signifies the end of the SQL statement, and the two dashes cause everything afterwards to be treated as a comment, which means this would be a comment. And by doing this, we are in fact just running this query, which will return the article with an ID of 2, whether it is set to public or not. And this is just one example of SQL injection vulnerability of a type called in-band SQL injection. And there are 3 types of, in total, in-band, blind, and out-of-band, which we'll discuss now. So what is an in-band SQL injection? So in-band SQL injection is the easiest type to detect and exploit, and in-band just refers to the same method of communication being used to exploit the vulnerability and also receive the results. For example, discovering an SQL injection vulnerability on the web page and then being able to extract data from the database to the same page. While an error-based SQL injection can be used for obtaining information about the database structure, as error messages from the database are printed directly to the browser screen. This can often be used to enumerate a whole database. Union-based SQL injection utilizes the SQL union operator with select statement to return additional results to the page. This method is the most common way of extracting large amounts of data via an SQL injection vulnerability. We're going to practice some in-band SQL injection. So let's do the level 1. In level 1 it says error-based SQLi. So hi, welcome to my very first article for my new website. And what we see is in the URL article $ID equal 1. So probably, and we can see it here, the SQL query behind it is select asterisk from article where ID equal 1. So we'll try and make it see where here if we can get an error. And yeah, so by putting an apostrophe at the end, we got an error which states syntax error or access violation 1064. You have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near, and you have those 3 apostrophe at line 1. So because we have an error and we know that it's in MySQL server, we can use the MySQL syntax and try and get an idea of how many columns there is in the SQL query. So here we can use the union select, and we'll put 1 to see if there's enough column. So we'll know how many columns there are. And it says no, the used select statements have a different number of columns. So we know that 1 isn't enough. Maybe there are 2 columns. And we'll try. Same error. So let's try with 3 columns, and so on and so forth until we find the right number of columns. And here there are 3. And we get my first article, article ID 1. Hi and welcome to my very first article for my new website. So instead of ID 1, we would like to put here ID 0 or something that doesn't exist. So we only have the answer from the union select. And here we go. So when we put ID 0, we get here article ID 1, then the number 2 is here, and the number 3 is here. So whatever we put in these 3 places will be placed like this. And why we do that is because, generally speaking, the website takes the first result and return it somewhere in the code. So we need the first part to have no result. That's why I put 0. It could be another ID. You have to tinker that and see if there is something where it doesn't give any result, and then we get the union select after it. So now that we know how many columns there is, we can start using this to retrieve more useful information, like what is the name of the database. So let's put it in place of number 3. So we can use the function database, which will retrieve the name of it. And here we get the name SQLi 1. Now that we know what is the name, we can try and retrieve the information about the table name from this database. So for that, we can use this. So group concat is a function that will concatenate the answers table name from information schema, is where we find the information relative to the database, and here we are searching for table names, so we'll go with dot tables. And then, because we already know the name of the database, we can go over, say, table schema equal and the name that we got here, so SQLi 1. And okay, there is an error. Where did I? So this here is where it's there was an error. It's not dot, it's underscore. So here we go. So the table names, there are 2 tables in this database. One is article and the second one is staff users. So now that we know the table name and we are searching for Martin's password, so Martin's is probably a staff member. So we should find the answer in the staff users table. But before being able to get the information from that table, we need to know what are the names for the columns names. So we'll change the table name here to column name. And then instead of getting it from information schema.tables, we get it from information schema.columns. And then now we know already what's the table name. So here we put table name and equal staff users. Now that it's done, let's get the answers. So now we know that in that table, the column name, so the table names is staff users and the column names are ID, password, and username. What we want to know is the password, and the username. So we are still getting information from, so now we'll get the information like this. We are getting the information from the table, which is staff users. Sorry. So we don't need column name. We already know what's the column names. So but we need to know username and passwords. So what we are going to use, we'll use this group concat to put into place the whole thing. So username, then we'll say to it to put whatever this character is in English, which I forgot the name. Oh, colon. So we put the colon, and then we add password, and then we'll say that the separator separator that we'll use here is this. So a new line, and we can send the information. So what we get here, as you can see, username, colon, password, username, colon, password, username, colon, password, and it's each one of them is on a new line. So now we can use this password to check for the password. And that's it. Here we go. Now let's go to blind SQL injection. So blind SQL injection is when we get little to no feedback to confirm whether or not the injected queries were selected. So because the error message has been disabled, but the injection still works. And all we need is a little bit of feedback to successfully enumerate a whole database. So blind SQL injection for authentication bypass is one of the most straightforward blind SQL injection techniques, and it is when bypassing authentication methods such as login forms. We aren't interested in retrieving data from the database, we just want to get past the login. And login forms that are connected to a database of users are often developed in a way that the web application isn't interested in the content of the username and password. It's interested in whether the two make a matching pair in the user's table. In other words, the web application is asking the database, do you have a user with the username Bob and the password Bob123? And the database replies with either yes or no. So we just need to create a database query that replies with a yes or true. So for that, let's do the level true of the SQL injection examples. So in level 2, we get a login form with username and password, and we want to bypass the authentication. So to bypass the authentication, we'll need here the SQL query behind it to return a true. So for that, let's just put something here. So you can see when I put admin in the user name, we have this, and I'm gonna put admin in the password, and we'll get this. So no results found, which is, yeah, normal. So what we want to do is for this query, going from select asterisk from users where username equal admin and password equal something, limit 1 to be true. So what we could do is put a statement that is always true. One of the statements that are always true would be or 1 equal 1. So what you see here is that part will be here between two codes. So we'll need to put a code first out to get outside of this, and then we would need to put the whole thing that comes after into a comment. So for MySQL, we would use this. That puts the whole thing after as a comment. As you can see here, after the two dashes, the rest is gray. So let's put login, and here we go. We were able to bypass the login, and we can now move to the next level. The next blind SQL injection that we'll talk about is the boolean based one. So boolean based SQL injections refers to the response we receive back, which could be either true or false, yes or no, on or off, 1 or 0, or any response which only have two outcomes. That outcomes confirms to us that our SQL injection payload was either successful or not. And I'm sure you already used to do something like that, like while gaming. So it's not there are multiple games that we did when we were kids, which was like one asking question or doing something, and the other one will just answer with yes or no. For example, Guess Who game. Yeah, the dinosaur edition, please. Anyway, and using this, we can still in fact enumerate the whole database structure and contents and finding whatever we want to find. Let's try some Boolean based blind SQL injection with level 3 now. So what we can see here, we are presented with this. There is the website where you get check user and username equal. So admin is taken. What we can do is, because we have this admin taken true. Let's try and modify this. So as you can see, the SQL query under that is working behind it is select asterisk from users where username equal the name that is here, limit 1. So like before, if we want to get the password for the admin and be able to log in, we will first need to know how many columns is in the user table. So what we can do is first find a username that doesn't exist. So this one doesn't exist. False, taken, false. Now that we know that the first part of the select will return a false information, and because we know that after that it's a limit, there is limit 1, we want that first part to return false. Then we'll use a union statement to get the information after. So what we'll do here, we'll close the username with a quote or apostrophe, then union select, and then we see 1, and we'll put the two dashes to put the rest of the SQL query as a comment, as you can see here. So let's see, false. Probably there is more than 1. Let's see if there are 2 columns, still false. And then, so you have to remember this, the SQL results that is here, or the SQL query that is here, normally they aren't shown because it's a blind SQL injection. Okay, so let's try with a third column, and now we get true. So now that we know the number of columns, we need to know the database name, as the only information we'll have is a boolean, so it's true or false. We'll need to find how to do it. So now we get to add where database, we know that the database function is what returns the name of the database, but because it's a boolean blind SQL injection, the answer won't be the name of the database. But we can use the like statement and try each and every character until we find the name of the database. So we'll start with nothing, just for you to see that we'll get true. Here we go. That's a true. Now, for each character, we want to know what's the first character of the name of the database. Let's try A, false. Let's try B, false. Let's try C, false. And so on and so forth until we get to S. And we get that the S is true. Now that we know that the S is true, I'm just going to write it down here so you can see it. We'll try to find the second character. So the second character, let's say A, it's false. B, false. C, false. And so on and so forth until we get to the Q. And Q is true. So the second part of the name of the database, the second letter is Q. Now, we continue like that until we find the whole name of the database. And here, I've already done it. So at the end, we get the name, which is SQLi 3. So now that we know the name of the database, we'll do the same thing to find out the table name and then to find out the columns for the table that we're searching for. So here, remove this, and we are searching, so from moving this, I'm writing it down from start. So from information underscore schema dot tables, where table underscore schema equal SQLi underscore 3, that's the name of the database. And now we search it for table name, and table name like, and the same as before. So we'll search letter by letter. So first letter, A, false, it's not an A. Second letter, false. Third letter, C, false. And so on and so forth until we get to the U. And U is true. So I'm just writing here. So now that we know that it starts with a U, we can continue. So same as before, let's try A, false, B, false, until we get to the S. And it's true. So it's US. And then we'll see that by the end, we'll get the table name users. So we know the table name. Now we can do the same, and we're gonna do the same for the column names. So instead of from information schemas dot columns, here where table name, so table name equal, and we know it because we just got it, users, and column name like, and the same as before, trying one letter at a time. So let's say A, no. There is no column that starts with an A. B, no. C, no. And let's do I, yes. Probably ID. And if we do ID, yes, let's remove the percentage to see if it ends with a D, yes. So there is a column name that's named ID. Now let's search for username. Maybe the other column is username. Yes. Lucky us. Now we know that we want the password. So let's try to see if there is a column that starts with a P. Yes. So probably same. Maybe it's password. And yeah. So the other column is password. So we can do that and enumerate all the columns that are there and all the tables also if you wanted to. Now we have enough information and we know that the username is admin, but we need to find the password. So let's go back here, remove the whole thing. So now we'll go with, we know that it's from the table users, and we'll see where username equal admin. That's the username that we want to search for the password for. And we need to find the password. So password like let's just put this. So it's true. Okay. Now we need to search for the first character. Let's say A, false, B, false, C, false. And we can try like that until we start with the numbers. So let's do 1, no, 2, no, 3, true. So the password start with a 3. Now that we have the first, let's search for the second character. So I'm just gonna guess maybe it's just numbers. So 1, false, 2, false, 3, false, 4, 5, no, 6, 7, and 8 is the second character. And we can continue like that until we find these numbers. And we get the password is this one. So let's put the password and here we go. Another blind SQL injection that we'll talk about is the time-based one. So a time-based SQL injection is very similar to the boolean-based. The same requests are sent, but there is no visual indicator of the queries being wrong or right. So instead, the indicator of a correct query is based on the time the query takes to complete. By introducing a time delay using built-in methods such as sleep or with the union statement, the sleep method will only get executed when the union select statement is successful. So, for example, when trying to establish the number of columns in a table, you would use the following query: admin code union select sleep 5 semicolon dash dash, which, if there was no pause in the response time, we know that the query was unsuccessful. So like on previous task, we add another column. And if this one produce a 5-second time delay, that confirms that the union was successful. and thus there are 2 columns in the query. So let's try it out right now. So same as boolean, but now we're gonna use time, which means we'll use the sleep function in a way or another. So yeah, let's try to put something that doesn't exist. As you can see, it's searching for a domain, but this isn't a domain. So we'll put the union, and we'll also need to know how many columns there is. So we'll use the sleep function. Let's do 5 seconds, sorry, and see if there is just 1 column. If there is 1 column, it will take 5 seconds, which no. So let's try with 2 columns. And with 2 columns, it took 5 seconds to respond, to produce a so it produced a 5-second time delay, which confirms that the query was successful. So there is 2 columns. Now that we know that there are 2 columns, we need to know the name of the database and the name of the table names and the table columns, same as before. So here, where, we add the where. So where database like, and we'll start with the A. The answer was in less than 5 seconds, which means the query was unsuccessful. So we'll change it to B. No, the database name doesn't start with B. C, no. D, and so on and so forth until we get to the S. And when we are on the S, we get the query hangs for 5 seconds before returning an answer. So we can think like the other databases all started with SQLi, so probably this one too. And we'll continue in the same way. So probably there was the 1, 2, and 3. Here should be 4. Let's try it. And yes, it is 4. Let's remove the percentage to see if it ends with that. It's exactly that. And yeah, so the table name, the database name is SQLi _4. Now that we know that, we'll be searching for the table names. So here we'll change here this to, here we'll do from information _ schema dot tables, and here we know the table name, the database name, so it's table _ schema equal SQLi _4. And what's missing is where the, like, we want to know the table name. So and table name like, and same as before. So we'll try with an A. Okay, there is a table name that starts with A. Now we continue. Let's see if what's the second letter. Let's put an A. No. B. no. C, no. D, no. E, no. No. F, no. And so on and so forth. Thanks to the magic of editing and so on, we end up with this. So that's the first table that we get, but that's not the one we are searching for, because what we are searching for from the name of the table is a table for users where we can find a username and a password. So let's search for another one. So instead of A, let's see with B. No, there is no table that starts with B. C, D. Probably there is an ID. Oh no. Maybe a username or user? Yes, apparently there is a table that starts with U. So let's see if user is correct. Okay, user is correct. Let's see if it no. Maybe it ends with an S. Yes. So it's users. So we can enumerate all the table names like that, but what we are searching for is probably in this table, the users table. So we can, from here on, we can just find out what's the column names for the table users. So same as before. Now, instead of saying from information schemas.tables, we get to columns, where instead of table schema, we put table name, and here it's the table name, it's the table users, and now instead of table name, we are searching for column name. And here we don't know, so let's put percentage. So this one is correct, and we'll get to search for column names one after the other. So if it's a users table, let's just put username and see. Yes. So here, let's try without the percentage and see if it works. It does work. So we know that one of the columns for the table users is username. Now we want to search for the other column. So another column, probably password. Let's just put password directly. And yes. So now that we know that there is the username and password, what we can do is try to find a username, and then once we have a username, try to find the password for that username. So let's do this. We are from table, we know the name of the table, it's from users, where username, because we know the column, and then again we'll put different things. So let's see if there is something that starts with an R. No. That starts with an A. Yes. Probably there is admin. So yeah. So what we can do now, instead of put in, let's see if it's admin or administrator. And apparently it's admin. So we have the name, the username, it's admin. So now what we are searching for is the password. So where username equal admin and password like. And again, we'll start by A, no, B, no, and so on and so forth until we get to the number. There is, 4. Yes, so 4 is one of them. The password for start with a 4. 1, 2, 3, 4, and so on and so forth until we get to this number, and we'll find that the password is that number. So let's log in, and yeah. And the last one that we'll talk about today is out-of-band SQL injection. So an out-of-band SQL injection isn't as common, as it either depends on specific feature being enabled on the database server or the web application business logic, which makes some kind of external network call based on the results from an SQL query. An out-of-band attack is classified by having 2 different communication channels, one to launch the attack and the other to gather the results. For example, the attack channel could be a web request, and the data gathering channel could be monitoring HTTP DNS requests made to a service we control. So here, an attacker makes a request to a website vulnerable to SQL injection with an injection payload. The website makes an SQL query to the database, which also passes the hacker's payload. The payload contains a request which forces an HTTP request back to the hacker's machine containing the data from the database. So now let's talk about remediation, or how to remediate this type of vulnerabilities. So there are multiple ways for developers to remediate these type of vulnerabilities, and some of them are the following, like prepared statements with parameterized queries. In a prepared query, the first thing developer writes are the SQL query, and then any user inputs are added as a parameter afterwards. So writing prepared statements ensures that the SQL code structure doesn't change, and the database can distinguish between the query and the data. So for example, we have here an example of prepared statements. Here we create the connection, then we check if the connection is okay. After that, we prepare the statement, and here you can see like preparing, insert into my guests, so insert into the table which name is my guests, and the user, like the columns would be first name, last name, email, and the values equal, we'll have here, instead of values like John or whatever, it's question marks. So the question marks are there for a reason, and they are to say that these would be values and not part of an SQL query. And then we bind the parameters of first name, last name, and email with the statement, and the 3 of them are strings, which is why you have 3s and then first name, last name, and email. After that, we set the parameters and we execute the statement. Another way of remediating is input validation. So input validation can go a long way to protect what gets put into an SQL query. So filtering characters to allow or disallow can be done through the usage of an allow list, can restrict input to only certain strings, or string replacement methods in the programming language. For example, here is a PHP form validation example where you have to put a name, an email, and choose a gender. So we use this like we take back the we get the elements from the post method, then we put the name. So here we have like from the post we have the variable name, and before getting attributed to the variable name, we first test it through a test function, and we do that with all the variables. So the test function here uses the trim function to strip any unnecessary character like extra space, tab, new line from the user input data. Then the strip slashes remove backslashes from the user input data, and the HTML special cars function converts some predefined characters to HTML entities like this. So the end becomes this, and the code becomes end code, and so on and so forth. And another way of remediating, so that would be escaping user input. So allowing user input containing characters such as code, double quote, dollar, and backslash can cause SQL queries to break or open them for injection attacks. So instead of doing that, we'll escape them by adding or prepending a backslash to this character, so which then causes them to be parsed just as a regular string and not as a special character. For more resources, you'll find linked down below the OWASP SQL Injection Prevention cheat sheet and the OWASP testing for SQL injection. Thank you for watching. I hope you enjoyed this video, and until next time, bye!